Hi guys, welcome back to another e-learning video. This video will be over the transformation k times f of x, where k is multiplying by f of x and it's on the front of the transformation right there. You can see it. It's not in the parentheses. It's on the outside. It's k times f of x. So we're going to look at some different cases here. You're going to have quite a few notes to make. So we're going to try things out. So you can see the graph f of x equals x squared. In other words, y equals x squared. So you can see the graph of x squared right here in black. And we're going to make this transformation, k times f of x, and I'm going to try out of where k is 4. So what happened? Our black line is our original graph, and it looks like everything's just going up a little quicker. It's going up a little quicker, and I want to try another number here, 7. Okay, so that's going up even quicker than the 4 one did. You can notice that it's going up much quicker. So what you're going to call that when numbers are positive and greater than 1 is a stretch. But I'm going to get to the notes on this here in just a second. So I'm going to show you one other thing here. Let's say it's 0.5. That's a positive number, right? Whoa, that's a little different. So the last two cases, it looks like it went up quicker. This time it looks like it goes up slower. Let's try another decimal between 0 and 1. Oh, an extra decimal point. See, that's going up a little slower as well. Let's try one final one. Yes, it's going up much slower. Okay, and what you're going to call these two things, I'm going to show you the two visuals. If the value of k is greater than 1, it's going to be called a stretch. So let's say that your number was 8. That's greater than 1, right? It's going to be called a stretch. You know how you put your arms up high to stretch? That's what's happening. It's stretching up high and it's going up quicker. When numbers are between 0 and 1, you're going to notice it goes up slower. So when the value of k is between 0 and 1, it's called a shrink. It's basically like you took your graph and you pushed it down just a little bit and widened it out. It's shrink. So if the value of k is greater than 1, it's called a stretch. If the value of k is between 0 and 1, it's called a shrink. And you're going to see the negative cases now. What if it's a negative 4? What happens with that? Well, you can look and see that not only did it go at a faster rate, but now it's not going up, it's going down. So what's going to happen is that negative that I'm pointing to with my cursor, that negative flips the graph. Okay, it reflects the graph over the x-axis. You see the x-axis that I'm going across with my cursor. So it reflects the graph over the x-axis. It flips it down. Or if it was a downward graph, it would flip it up. So it's going to reflect the graph. When you have a negative, it's going to reflect the graph. And you're going to also see that it's going at a faster rate. So at this rate, you can see that it's a little bit slower than this rate is. It's going down at a faster rate than it was going up. So this is called a stretch, but it's a reflection and then a stretch. So if the value of k is since it's negative numbers, if the value of k is less than -1, then it's going to be a stretch again, but it's going to be a reflection over the x-axis and then a stretch. Okay, what if the value of k is -0.2? So it's the same rules as a number between 0 and 1. When k is between 0 and 1, it was a shrink and things widened out. So between 0 and -1, it's going to be a shrink again, but it's going to reflect because of that negative. It's going to reflect over the x-axis, and then it's going to widen out. It's going to be, that's called a shrink. So those are the things that I want you to get out of this video, is that when the value of k is greater than 1, say 5, you have a vertical stretch. When the value of k is between 0 and 1, you have a shrink. It widens out. It's a slower rate. When the value of k is between 0 and -1, excuse me, between 0 and -1, you have a reflection and then a shrink where it widens out. When the value of k is less than -1, you have a reflection and a stretch. So those are the things that I want you to get out of this video, and make sure you've taken those notes down somewhere. There are wonderful notes on Google that you can find for all of these transformations, but just make sure you're taking down some sort of notes. And if you would just bear with me, please, I will open up my whiteboard and I will add to the notes we had previously. Almost. So these are the notes we had previously, and I'm going to go ahead and add to them. It's going to take quite a few notes. I wish I had written them further to the right, but I wanted you to be able to see them and then see your new ones. So k times f of x, if k is greater than 1, it's a stretch. If k is between 0 and 1, it's a shrink. Okay? Then the other thing you need to say is that a negative reflects the graph. I can't write for some reason. Let me change this to a little bit better writing. Reflects the graph. Okay, it reflects the graph, and I should also add over the x-axis. Okay, so those are the notes I would make, and the value of k being greater than 1 works the same as it works for it being less than -1. It's just about the number being, the absolute value of the number being greater than 1. It's a stretch. So that's something you could also add to this. If you want to think about it that way, if the absolute value of k is greater than 1, you have a stretch. And if the absolute value of k is between 0 and 1, you have a shrink. And the negative reflects the graph over the x-axis. Okay, so those are the notes that you should have so far. And then we'll add one more transformation next time. If you have any more questions, please email me or ask me during live time.